Okay, y'all. I'm probably going to be going back over this on Monday because I'm I'm hoping that y'all can understand how to do limiting reagents with what I go through. But if you have questions, I think I can take care of it Monday, and I'll push stuff back, and we can still have our test by Friday. But today we're doing what is called limiting reagents. A reagent is a reactant. Okay, so that's the stuff on the left-hand side of the arrow. You have to figure out, is it limiting or is it in excess? Normally they just talk about two of them. So you need to know what it means if something is limiting or if something is in excess, which is why that's today's opener. If it's limiting, you're going to run out. Like you hit a limit and you can't do any more. That's why they call a speed limit a speed limit. You're not supposed to go above it, even though it seems like everybody does. If something's in excess, you're going to have extra left over. You have more than enough to make the reaction go. And you're going to be figuring out which is which. Limiting reagents. Okay, this is not chemistry. Okay, this is like McDonald's ad. It says one hamburger, which is HB, is made up of 2 beef patties, which is all beef patties, ABP, 2 sesame seed buns, SSB, 4 pickles, P, and 1 packet of ketchup, which is K. This is similar to like using a chemical symbol for an element. That's basically what this is doing. So we're going to create a reaction for this. So it's one hamburger is made up of, okay, so what it's made up of are the reactants: 2 all beef patties, 2 sesame seed buns, 4 pickles, and 1 packet of ketchup. That makes a hamburger. We're literally doing the same thing with chemical reactions, but we're now going to figure out which one of these is going to control the maximum amount of hamburgers you can make. So we have I just repeated the equation from before. We have 20 all beef patties. I'm going to put that one here. We have 50 pickles. I'm going to put that one here. I have 10 packets of ketchup. I'm going to put that one here. And I have 16 sesame seed buns. I'm going to do 4 separate ones to figure out what's who's going to be the limiting reagent. Okay, so I'm going to, like I said, it doesn't matter the unit. I'm going to drop it and I'm going to change it to what I'm going to for every separate one. So I'm doing 4 one-step equations. And I'm going to do the pickles to the burger. And then I'm going to do the ketchup to the burger. And I'm going to do the sesame seed buns to the burger. And then I'm going to use these coefficients to drop into my holes. The hamburgers are all going to get a 1. Okay. The all beef patty gets a 2. Oh, well, okay. I thought I was going to do all of them, but I didn't. So I can cancel out my all beef patties and and I don't have to do times 1. So 20 divided by 2, I can make 10 complete hamburgers here. Move to the next one. Pickle gets a 4, hamburger gets a 1. This is the pickles would cancel. 50 divided by 4 would be 12 hamburgers. And then my ketchup would get a 1. So I can make 10 hamburgers. And here my sesame seed bun gets a 2. So I can make 8 hamburgers. So the limiting reagent would be the one that makes the fewest amount of product, which is a hamburger. So your limiting reagent is a sesame seed bun because it makes the fewest complete hamburgers. If you were just doing a mole calculation to figure out limiting reagent, it's a 1-step. However, most limiting reagent questions ask for a 3-step mass, which is what we did 2 days ago. And then yesterday was the workday over this. Limiting reagents stop the reaction. That's the one you have to do your calculations with to figure out how much product can be made. Excess reagents have extra left over. They don't stop the reaction. So when you figure out which is limiting, if I ask you how much product could be made, you have to use the limiting reagent. I can't use the excess reagent. If you're given both reactants, you compare them to each other. Pick one. I always pick the first thing that's listed just because I do. You're going to have known starting amounts for both. You're going to calculate with one of the ones that you choose how much of the other one is necessary. If you don't have enough, then it's a limiting reagent. If you have excess of it, then the other thing was the limiting reagent. When I go through the math, it'll make more sense, and this might be why we have to go back over this on Monday. Your question tells you how much of each reactant you have. Your answer tells you how much you need. You just have to figure out which is which. Right, so it's a three-step mass-mass. We have our equation and we have two starting substances. I'm just going to pick the sodium because it's on the left. Because they're in grams, I need the molar mass of sodium straight off the periodic table. Chlorine, there's two of them. 2 times the 35.45, I think it is 70.90. You really could pick either one. I'm going to pick the sodium. So just like what we did the last 2 days, you drop the mass and you go to its mole, where the mass would get that and the mole would get that. Then you're going to change between your substances using your coefficients. And then to get to grams, you're going to bring down moles of the new substance and change it to its grams. So I'm going to fill everything in. 1 sodium moles, 22.99 grams. If I go too fast, please just pause me. I'm trying in 8 minutes. I'm trying to finish the next 3 slides. Chlorine gets a 1. Sodium gets a 2. The mole gets a 1. The gram gets to 70.90. I'm going to clean everything up real quick. And I'm going to do 5 times 70.90 divided by 22.99. So this says if I have 5 grams of sodium to completely react, I have to have at least 7.71 grams of chlorine. This is what I need. This is what I have. I don't have enough. And so my limiting reagent is the chlorine. You're going to ask what happens if it's the other way around. I'm going to go through another one of these and I'll show you that. I literally have 7 minutes to do it. So if I go too fast, please just pause me. And if those of you are remote and you're online from today, I am doing tomorrow's. I'm recording it right now. Oh, well, you already see the answer. Let me fix it. Let me fix it. Add animation, even though you could just see the entire thing. Pretend like you didn't. Okay. New reaction. You have to calculate the masses of the starting, which is the oxygen, and the masses of the ending, which is the acetylene. That's the C2H2. And this is the mole ratio. I'm going to drop in my starting. Like I said, I'm picking, I picked the acetylene first because it was listed first. They're both starting with 100 grams. So you're going to drop and change to its mole using these. You're going to drop and change to the other substance using these. Then you're going to drop and change to its mass using these. And we'll fill everything in. By all means, pause me. I'm going to cross out and get rid of my ones. So it's going to be 100 times 5 times 32 divided by, you would open parentheses, 26.04 times 2 and close them and hit enter. And it says, even though you just saw this because I made a boo-boo, says you need 307.2 grams of oxygen. I only have 100 grams of oxygen. I don't have 307. I don't have enough. So oxygen gas would be the limiting reagent. So, I did it again. Poop. So I'm just doing the same problem, but from the other point of view. It's the exact same problem. Same masses. I'm going to drop everything like I did. It's just in reverse. But I'm going to show you, because you're what happens if you have enough? How do you figure that out? Well, I'm going to put everything in. Cancel everything out. Get rid of my ones. So if instead I do it from the oxygen's point of view, I would do 100 grams times 2 times 26.04 divided by open parentheses 32 times 5 And it says that if I have 100 grams of oxygen, I need 32.55 grams of the acetylene. I have enough. So if I have enough acetylene, it's in excess. So oxygen is still the limiting reagent. Your problem tells you how much you have. Your math tells you how much you need. You compare them. If you don't have enough, then that thing is the limiting reagent. If you have enough, then the thing that you started with was the limiting reagent. With this, I need 32.55 of acetylene. I have 100. I have enough acetylene. So this oxygen is the limiting reagent. I think that's it. That's it. All right. So you, by all means, go back, pause. We will talk about this Monday. If you have any problems, we'll figure it out. You guys have an assignment that goes with this. If you're confused, it's okay. We'll take care of it on Monday. You're more than welcome to try it. And make sure that you, if you did not turn in the first mass one, that you get that stuff turned in.